Hey everybody, tonight we have a evaluate slash simplify problem with a pretty unmotivated looking large constant here. Now often these problems just evaluate to some integer. It's nothing says that has to be the case, but that seems like most of these sort of, shall we call them competition problems, just turn into some integer. And normally there's some nice accompanying algebra, and tonight's no different. You can see that you have the sum of 2/5 powers right here. And there's a very well known sum of 2/5 power formulas. It's just, I'm not going to go through it, but it alternates and a lot of stuff cancels out. And so a lot of stuff cancels out on the right hand side, and you get this left hand side, which is the sum of two powers. Okay. And that sum of 2/5 powers, excuse me. All right. Now, it makes sense to do all the algebra I'm showing you right here. You divide through by this part right here. Okay. And at least we have something that gives the possibility of a constant here in the middle that might meet the requirements here. So moving along, we can actually factor, and the factoring is not necessary right here, but I think it's advisable. It just makes the numbers smaller, right? So we can factor in a, b out of here, okay? And then if we pick the obvious choices here, 20 and 70, here's how it breaks out right here, folks. And again, I'm just putting 20 and 70 everywhere I can, and hoping that this middle part is the constant that was in the problem, the initial problem. And so this part ends up being, let's see, we have 20 to the 5th plus 70 to the 5th. Okay, and again, all of this stuff downstairs. Okay, so let's see, this is 20 to the 4th. Okay, right here, this is minus 1400. Okay, right, and the values inside the parentheses end up being 3,900. Right here, folks, if you take 20 squared, that is 400. This is minus 1,400, right? That's minus 1,000. This is 4,900. So this would be 3,900 right here. And this is plus 70 to the 4th still. Okay, but you see that's exactly, it's in this form, and this number conveniently, and I'll just write it, this number right here, when you multiply it out, actually is our magic number up here, 5,460,000. So let me go ahead and just put that directly underneath here. This guy right here is I'll just write it right here, folks, 5,460,000. That 5,460,000, and of course that's what we wanted. And so this is all of this stuff by the algebra that we started with at the very beginning is just the sum of 20 and 70. Okay, so this is actually just equal to 20 plus 70. And it simplifies nicely to 90. Okay. So again, folks, not too much of a challenge here, other than just noticing that you need to take this. And again, this looks awful, just where did this come from? But again, if you're familiar, the only way you can get to first base, I think, is utilizing this algebraic identity. I don't know of another approach here really that would get you anywhere. So once you see this algebraic identity is key, the rest of it is just kind of crunching through it, nothing too imaginative or elegant going on here. But anyway, this is equal to 90. All right, good night.